Today, we're going to be talking about polynomials and classifying them and looking at end behavior. So before we can start the discussion, we need to understand all of our vocabulary. So there's going to be a list of terms here and definitions. And you're going to have to write these down. So if you need to, you can kind of stop the video and copy all of these definitions down. So the term, monomial, binomial, trinomial, all of those terms you need to be familiar with. So again, go back, pause it, to make sure you understand what those vocabulary words are. Now, most of this lesson, there's not going to be too much calculation. It's going to be about analyzing, thinking, and applying our current knowledge with what we have. So when we're looking at polynomials, we're going to kind of go through some different scenarios on what they can look like and how we can describe them. The first one, the first example that we have, and I will construct this chart that you can fill in as we go. So if you need to pause it to start this, go ahead. So the first one, our equation is just plain old 8. There's no variables in it. It's just that. Now because there is no addition or subtraction, that is just one term. Okay? Because there's no variables in it. We want to think about the degree of a polynomial, which is the highest exponent. If I don't have any variables here, there's no exponents to go with them. So whenever it's just this, the degree of this is 0. Now this would relate in a horizontal line, and this would be called a constant function. It's constant because the y values are not changing. They're not increasing or decreasing as they go. They're staying constant at 8. There's one term here, and that would make this a monomial. So we can fill that in. Remember, monomial, mono means one, and it's one term. The second one, we have 3x plus 4. So the first thing is, what is the degree? Now here, we do have an x value, but you know there's nothing written here as an exponent. However, there is an invisible 1 that we need to include. And we studied a ton of these kind of problems in Algebra 1. So the degree of this function is 1. And this is a linear function, meaning it will create a straight line. Because there's a plus here, I see that there are 2 terms, which makes this, because there's 2, it is a binomial, we could describe this as. The next one, and if you notice, all of these are written in standard form. It's important to look at that, because we're always looking at this first or the leading term when we're looking at identifying all these. Highest exponent is 2. We studied quite a few of these recently. These are what we call quadratics. Right. There's 1, 2, 3 terms here. 3 terms makes this a trinomial. Next one. The degree is 3. This is called a cubic function. Again, there are 1, 2, 3 terms. Again, if you notice, the terms are separated with addition or subtraction. This is another trinomial. Fourth one. Actually, the fifth one, I'm sorry. The highest exponent is 4, so that's a degree of 4. This is what we call a quartic function. And again, this has 3 terms, so therefore it's another trinomial. The last one we have, it's x to the fifth. This is what we call a quintic function. Now here, there's a lot of terms. 1, 2, 3, 4, 5. There's 6 terms here. We could describe this as a polynomial of 6. There's nothing special after 5. Just gets more and more complicated. So we can kind of just stop and say that this is a polynomial of 6 terms. So when we're looking at this, you want to be able to refer back to this chart over the next couple days. Now at the bottom of the notes, it says we can also classify functions with several different characteristics. Okay? We did it with naming them, identifying the degree, and then naming how many terms are in it. We can also identify, just looking at the function, some things like how many zeros it can have, the end behavior, how many changes in direction, like how many turns we have, and how many relative minimums and maximums. Today, we're just going to focus on end behavior, because this is a very important thing to think about. Now, when we're talking about end behavior, talking about just the ends of it, we know that all of our polynomial functions, the domain is all real numbers. It goes on forever to the left and forever to the right. Now when we calculate this or think about it, it's nice to know where it ends. It helps us in graphing. It helps us in identifying what our curves are going to look like. These are going to be a lot more complicated than just quadratics or lines. So what we mean by end behavior is I just want to care what's happening on the ends, going left and right. I want to know that this graph is going down that way and then finishing up this way. That's all I want. The middle we do not care about right now. That's not where it ends. It ends here and here. This graph could continue to do this. All right, we don't care about that. We just care about this end. And these rules over here will work every single time. So you want to start copying this down. And we're going to work through this and use this chart as well. If our degree is odd and the leading coefficient is a positive number. Again, what the numbers are does not matter. We just want to know if it's odd or even and if it's positive or negative. If the degree is odd and it is positive, it will end going to the left, down, and it will finish going up. If it's odd and it's a negative coefficient, it's going to flip around. It's going to finish going up and then finish going down. So if you notice, if this is odd, they're going in opposite directions. If they're even, they'll be ending in the same direction. If it's even and it's positive, it's going to look like a parabola. It's going to end like that. If it's even and it's negative, it's going to end like this. So as we go through and work with more of these over the next couple days, keep these two charts handy. You're going to need them.